Tonight I'm going to be working on the Pitot Static system that came with the CH750 Cruzer kit, and I'll be talking a little bit about Pitot Static systems in general, and I'll be describing this little Pitot Static system that came with the Cruzer. This will be the Pitot Static tubes that we're going to be installing on the CH750 Cruzer. And by no means do you have to use one like this. So a lot of guys get a different Pitot tube and then put static ports on the side of the fuselage. But this particular one, the bottom tube here is the Pitot tube. The top tube is the static port. So the static port is closed off on the front end, and there's three little holes drilled in it right here, here, and down underneath. That's for sensing static pressure. And then the Pitot tube, the actual Pitot tube on the bottom, is open on the end here, and it's so ram air can enter the tube. And it kind of depends on what you want to spend. You could stick with this one and install it. They're only about $80–90 through Zenith, or you could spend hundreds of dollars on a different system. The Pitot tube was invented by a guy named Henry Pitot way back in 1732. The Pitot tube is used for airspeed indication, and some of them are electrically heated to prevent ice buildup. The static port of the Pitot tube system reads ambient air atmospheric pressure, and it is responsible for airspeed, altimeter, and vertical speed indication. The static ports on certificated airplanes are usually on the side of the fuselage in areas where there's less disturbed air. And like I showed you a minute ago, the Cruzer comes with the kit is a Pitot Static tube, which has the Pitot tube and the static tube basically attached together. Of course, if an aircraft is going to fly in IFR conditions, the Pitot tube needs to be heated. And this will prevent ice from building up and blocking the Pitot tube. Brings me to a story that happened to me like 30 years ago. I was a bad boy and didn't check the Pitot tube heat that it was working before I took off on an IFR flight. So coming into an airport, I was doing a VOR approach in the clouds. Ice began to build up on the windscreen. I could see it, the leading edges of the wing. All of a sudden, my airspeed began decreasing as I'm going down through the approach, lowering my altitude, and it would decrease more and more and more. So I could see the ice build up on the Pitot tube, and the Pitot tube switch was on. So immediately I knew that the Pitot tube heat was not working. So I wasn't super alarmed by the fact my airspeed was decreasing as I lowered altitude, because I knew that's what would happen. And the 172 I was flying had its static ports on the side of the fuselage, and they were not blocked. Now if your static port becomes blocked, it would cause the ASI, altimeter, and the DSI to have malfunctions, such as at the altitude where the blockage occurs, the airspeed indications would be normal. At altitude above where the static ports become blocked, the airspeed would decrease. Then, as altitude decreases, the airspeed would increase, and that's to show that you have a blockage in the static port. So basically, the trapped pressure in the static system causes the altimeter to remain at the same altitude where the blockage occurred, and the vertical speed indicator will remain at 0. On small aircraft, the Pitot tube is usually mounted on the wing, usually the left-hand wing, where it faces into the relative wind. So the Pitot tube itself measures ram air, and the static ports, they will read static air pressure. So anyway, this is what I'm going to work on tonight, and I'm going to hook up the static and pitot lines and get them ready to install, and this will be mounted underneath the wing. I already have this fit for underneath the wing and the hole made for these lines to fit through. Here, if you can see it here. Here's one of the static holes is right there, and then there's two more that go around on this top static tube, and you can see it's closed off on this end, and then the pitot tube that uses ram air is open.
Some of the problems I had on this installation was I had to make the hole a little bit bigger on the wing where the tubes come out. I originally had the red tube connected to the pitot tube, and the blue tube was connected to the static tube. Here I am trying out some new grip tight zip ties. They seem to be pretty good, but I haven't decided if I'm going to use them for sure yet or not. I had to move the red tube to the static and the blue tube to the pitot tube. The red and blue tubes had a twist inside the wing, so when I reversed the red tube to the static and the blue tube to the pitot tube, it undid the twist and air was free to flow through the pitot tube. I also tried to use a tube cutter on this nylon tube, and it cut through okay, but it kind of beveled the hole a little too much, so I didn't try that again. I just used a sharp box knife to cut the tubes, and then I used a jeweler's file to file away the edges, rough edges, just a little bit around the outer diameter of the tube. Here I'm clecoing in the pitot static tubes to the bottom of the wing. And next I'm testing that air flows properly through the pitot tube and the static tube. Later on, when we get this system all hooked up, we'll do a proper leak test on it. Here's just some different views of the pitot static tubes clecoed in place. Of course, this is the bottom of the wing, and the tubes are facing to the leading edge. And it's placed according to the plans, measurements from the rivet lines. Here are the pitot and static tubes as they exit the trailing edge of the wing spar. Here are some 1/4 inch quick connects we'll be using when routing the static and pitot tubes through the cockpit. We'll be using some bulkhead quick connects where the lines will be coming through the fuselage from the wing. And the reason being for that is if we ever have to take the wings back off, then it would be much easier just to disconnect the static and pitot tube lines when removing the wing. Hope you enjoyed the video. Thank you for watching. Please like, comment, share, and subscribe. Thank you.